5-2. Let's integrate logarithms. How's that sound? Okay, so the top is the derivative rule. Yes? Mm-hmm. So you take u prime over u as the derivative rule. Yeah. So we're going to look at specifically this integration rule because it applies for everything. And it says the integral of 1 over u du, which I rather write here, because isn't du the derivative of u? Yeah. Yes? So I showed you all these rules, and then I'm going to box this last one and say use it. So if you have the integral of u prime over u, then it is the natural log of u plus c. If you're given an expression that happens to be u prime over u, you can use natural log. Wouldn't that be a lot easier than all the other rules that we use? I think so, because that's pretty simple. Now you will see 1 over x, and you will just jump to the natural log of x. And I usually think of it this way and this way. This is just a sloppy way to write it. It's too much detail.
So do I need to write that other one too, or can I just write this bottom one that you boxed 50 times?
This one would work for all of them, wouldn't it?
Yes.
Because the derivative of x would be 1?
Yeah.
Yep. Okay, so to see what we can do or how we can do it, we're hoping when you get a fraction, the first hope you should be that it is a natural log. Okay, so in order for it to be a natural log, it has to be u prime over u. So what is u? X. So u prime would be 1 dx. Okay, so, well, we have x, but we have a 2, so how would you make a 1 a 2?
You make a 1 a 2 by multiplying the 1 by 2.
So we could write this as 2, the integral of u prime over u. Because u prime is du, correct? So, well, if I have u prime over u, then what integration rule do I use?
The one you just gave us.
So it's going to be 2, the natural log of the absolute value of u, which is what? X plus c. Well, this 2 was a what?
It was an exponent.
It was an exponent. So now I just can write the natural log of x squared without the absolute value. Why? Because square will always be positive, yes? Can you be nice to that? Because one broke yesterday.
I just went down.
I know, but don't go down so rough, please.
It went down like that, so
Okay.
I held the button.
Okay. Put your feet on the floor when you do it. Okay. Integral of 1 over 4x minus 1 dx. I know today is all going to be logarithms, but in general, as we move along, if you have a rational expression, that means a fraction, your hope should be that you can deal with it with the natural log because it's quick and easy. Because they're not going to be all quick and easy. So the first thing you do is you go, okay, well, I would need u prime over u. Some people prefer to put u prime and u and work backwards because that's the way it would sit. It doesn't matter to me which way you would like to identify them. Actually, you have to identify u first, correct? But it doesn't matter which order you write them in to me. Okay, so what is u?
U is 4x minus 1.
4x minus 1, because u, if it is natural log, is always going to be the denominator. And so u prime is 4 dx.
Yeah.
Okay, so I have a 1. Could I make a 4 a 1?
Yeah.
Yeah? So I can use natural log. So what do I have to put in front of it? 1 over 4, the integral of u prime over u. So if you have u prime over u, then it is the natural log. So you have 1/4 the natural log, the absolute value of 4x minus 1 plus c. Now I think it's really funny because the textbook puts the 2 back as an exponent, but they don't put the 1/4. And I'm like, if you're going to do the 2, I think you need to do the 1/4, don't you? So this would be the natural log of the 4th root of 4x minus 1 plus c. And once I put the 4th root, I don't have to have the absolute value in there either, do I? But like I said, the textbook leaves it as 1/4 the natural log of the absolute value of x minus 4, or x minus 1, 4x minus 1. There you go. Good? Okay, so this is just saying the words that I just said to you. In this example, we used an alternative form of the log rule. Look for quotients in which the numerator is the derivative of the denominator. Is that not what I just said a million times? Okay, so it says find the area. Well, we find the area by using what? Integration. So we're going to actually be specific. It's definite integration, yes?
Yes.
Okay, so the integral from what to what? From 0 to 3? That is a really good integration sign. Okay, of?
X over x squared plus 1 dx.
Okay, so we're crossing our fingers that the numerator is the derivative of the denominator, correct?
Yeah.
So the denominator is?
X squared plus 1.
And so the derivative of that would be?
Be 2x.
Dx.
Dx.
Okay, so is that possible here?
Yeah.
Yep, we just need to add in a what? So, no. A 1/2.
See, I never know.
Okay, it should be 2 and there's a 1. So how did 2 turn into 1? 1/2.
Oh, yeah.
So it's how this turned into that. Okay, so 1/2 the integral of u prime over u. So it's 1/2 what?
This thing.
The natural log of x squared plus 1 from 0 to 3. So basically you're doing exactly what you've been doing, but I gave you a way to make the fractions easier to work with, right? Or the rational expressions. So I plug in 3 and 0. So 1/2. The natural log of 3 squared plus 1 is 10. Minus the natural log of 0 squared plus 1. So the natural log of 1. Okay, well, we don't know the natural log of 10 without a calculator, but you better know the natural log of 1 without a calculator.
0.
It's 0. So we have natural log of 10 minus 0. So we just have 1/2 natural log of 10. If they wanted anything further, you would put it in a, and you would get 1.151, approximately. So, any different than what we've been doing?
Pretty different, I think.
I don't think so.
Pretty similar.
It's just substitution, basically, right? Okay, so we got more. That's all we got. So is it going to work for us?
Yeah. Without any additions, I think.
Really? So I got x cubed plus x. So I get 3x squared plus 1 dx. Yeah, we don't have enough to put anything in, do we? So we have the natural log. Nope. I was skipping right to the answer.
Stop that.
I know. U prime over u. So we get the natural log of,
X cubed plus x.
don't forget your c. I did not space. Oh, that's why. Sorry. Must be still on square mode.
What's square mode?
Like this frame is square, not.
You can draw off the edge too,
Yeah, that's why I can draw over there.
in the black.
Oh, I see now.
Okay. So what am I going to do first? U and u prime. So u is tangent of x. How do I know it's tangent of x? It's the denominator. And so the derivative is
Secant squared of x.
secant squared of x. Can I just jump to the answer?
Yeah.
So what's the answer?
The natural log of tangent of x plus c.
The natural log of the absolute value. Ooh, we forgot what on the other one.
Yeah.
And I let it happen. What did we forget?
Here is your fault. The absolute value.
And that one we do have to have an absolute value. Why?
Squared anywhere.
There's not even exponents, right? Okay. The absolute value of the tangent of x plus c. Don't forget that c. Now, I do think it's kind of helpful if you write the u prime over u, because once you do that, then you can just skip to the answer on the basic ones. Am I good? No.
You said we were done.
No.
You said we were done after
You
this.
did.
I just have examples. That's what I meant. Like, we have examples. That's it. I think I have 2 more, maybe. I mean, if you think you got it, we can stop. How about I put the 2 up there and you try 'em? Are you done yet?
You can go, sure.
Okay. I'm a little impatient today. Okay, there you go. There you got 2.
We spent how long with you?
Oh, just hush.
Planning a girls' trip.
Now,
Our education-
there are more, I guess. Ooh, that's fun.
That's not gonna be fun.
Can I start working? And I will tell you on both of these, if you look at the book answer, they left 1/3 and 1/2 out front.
I have a question.
Mm-hmm.
So for the cube root,
Mm-hmm.
does that need absolute value?
Oh, because it could be negative. You're correct.
Okay.
Yep.
Just put the absolute value.
Yeah. Because it could come out negative, couldn't it? Good?
Yeah.
Okay. So everything so far has been nice. Like the degree of the numerator is exactly 1 degree less of the denominator, and it works out great, right? What if the degree of the numerator... What if the degree of the numerator doesn't work out? Because is that going to work out?
No.
No. So if the degree of the numerator is equal to or greater than, is it going to work?
No.
No. But if we did something called long division,
Why do we keep having to do this?
is it possible to get down to make it easier?
Probably not.
Let's see. Why do we keep having to do something you told us we were going to have to keep doing? I don't know.
I don't know.
Okay, so x squared, we got to fill in the gaps, right? X squared plus 0x plus 1. You're going to divide that into x squared plus x plus 1. By doing that, we're going to find our quotient, which we're not going to deal much with, right? We'll take the derivative of, integral of it separately. We can divide this up into addition problems. So we have to multiply by what, 1? Or we have to put a 1 on top and a negative 1 out on the side. So negative x squared plus 0x minus 1. Because I get 0. And they don't get 0. Oh, never mind. I don't get 0. We don't get 0, do we? We get what? X. Now, we can't get x squared to be x. That's not how this works, does it? Okay, so we can rewrite this integral as the quotient, which is 1, plus the remainder over the divisor. Now we have 2 terms, correct? And our integration rules say I can integrate one term and then integrate the other. So 1 is going to be easy to integrate, correct? What's the integral of 1? X. Now the other term we have a rational expression with the numerator of a less degree. And actually 1 less degree, yes? So let's see if log will work. So u prime and u would be x squared plus 1, and u prime would be 2x dx. So can we make this work? Yes. So what we have is the integral of 1 plus, what do we have to throw in front of there? How did the 2 go to a 1? 1/2 the integral, and do we have u prime over u? So the integral of 1 is x plus 1/2 the natural log of the absolute value of x squared plus 1 plus c. And we're just going to leave the 1/2 there because they've been doing it. And actually, do I need the absolute value? I don't have to have the absolute value. And it is always good to be aware whether the absolute value has to be there or not. If you put it there, it's not wrong. Okay, so, but if you don't put it there when it has to be, then it is wrong. So just be aware of that. Sometimes I'll notice it before, sometimes I don't. If I notice it afterwards, I usually just leave it there and don't worry about it. Because the squared plus 1 is always going to be positive, isn't it? Okay, then we also could do something like what? Substitution. Are we done for the day? You want to do substitution tomorrow?
Yes.
Okay, so your assignment I gave you was just one big one. I didn't break it up into 2. I think substitution will get you through half of it. Hopefully. Where are you at? Like 50. I'd like to get you at least to 57. Let me make sure. A lot of them do say verify with your graphing utility. Have I showed you the integration button on your calculator? I thought I did.
Pretty sure you did.
I'm pretty sure I did
What
too.
gives the swirly S?
The integral?
Yeah.
Yeah. So quite a few of them say find it and then verify with their graphing utility. So you can do that, or you can go on the integral calculator, or you can just look in the textbook.
I was gonna say, or you could just verify.
I think I would use your calculator a few times so you are okay with doing that since you have them. But I think we'll stop because I'm pretty sure it gets you over at half today. And then tomorrow we'll do substitution. And I think we'll call it good then. Oh, we do have a few. We have the trig formulas we have to do. So if you hit any trig today,
Burn.
no, don't burn them. And you will hit a few, okay, 37, 39, 41. When you get to your trig ones, just don't do them. We'll do them tomorrow.
I wasn't gonna do it anyway.
Yeah, you probably wouldn't do nothing. Just don't do nothing.
I was gonna do tricks.
Okay, so we're good for today.